Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, July 30th. Looking at significant wave heights for the South Pacific Ocean, we see not a whole lot going on. It sure looks like the southern branch of the jet stream is displaced south, high pressure is in control, and there is no swell-producing weather systems, obviously, in the California or Hawaii swell window. But let's get into the details and verify what's going on. As usual, we'll start our tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales, and when they do form, help direct their tracks. We're looking for a trough. That is a dip in the jet. A dip in the southern hemisphere is actually going to the north. Something that goes up like that and down like that. That would help support clockwise flow aloft, and that is the hallmark of low pressure. And also, it would support low pressure down at the ocean surface. And of course, low pressure generates winds. Winds generate waves, or seas. And seas, as they radiate away from the fetch area, produce swell, which ultimately results in surf when it arrives at your beach. Clearly, we see a split jet stream pattern. That is the northern branch of the jet here running roughly on the 30 south latitude line. Cross like that. Yeah, a couple little bumps up to the north here, but typically, and you'd say, oh, those look like troughs, but not in the northern branch. It's this southern branch that's the one that really feeds storm development. And it's running generally down here around 63 south. The ice line for Antarctic ice is somewhere around 65, and so there's not much room, even if there were a trough here, to support storm development. Everything's over ice right now. Not a good sign. So this is called typically a zonal jet stream pattern. Two branches of the jet running parallel to each other across the South Pacific. Anyway, let's put this into motion, see what's going on. Roll it out. Don't see a whole lot going on. Here we are a bit, if anything, here's a ridge pushing further south on Tuesday, August 1st. And again, about the same thing going on here in the southeast Pacific. We'll roll it out further, look for some signs of hope. Now here's pretty much about as zonal a pattern as you're ever going to get. North branch running right there, south branch running right there. No troughs, anything going on. That's on Wednesday evening. We'll just roll this out. Then you sort of get the hint right there. This is, what is this, Friday night of this coming week. You see something that starts looking like a trough trying to develop in the southeast Pacific now, Southern California. San Diego's right around, about 117 or so west, somewhere right around in here. So yeah, there's a little bit of a gap here for a storm to develop. Let's see what happens. You get a little bit of energy pushing north, not a lot. What is that, 130 knot winds into Saturday during the day. And then another trough starts building a little bit more organized, or just sort of amplifying the existing trough. 18Z Sunday, that's about 11 a.m. Sunday, California time, into Sunday night, another trough. And so there's some hope way out in the, we're talking next weekend in the southeast Pacific, but the southwest Pacific pretty much locked down. So let's put this in perspective. Typically, when you have El Nino in play, the trough pattern tends to be here under New Zealand, especially the year after a strong El Nino. Yet you tend to get this semi-permanent sustained trough over here. The other theory is that during La Niñas, we said El Nino, right? I hope I did. Anyway, during La Niñas, the trough, the area most likely to get troughs tends to be the southeast Pacific. And that's what's been going on all summer. Most of our activity has been right here, except for very early in the season. We had a couple of gales over in this area. We got a couple of southwest pulses into California and Hawaii. But now all the activity has been over here. We think that's a symptom of La Nina. That's pretty much cut Hawaii out of the action. It's been great for Southern California in that Southern California tends to do best on very south-angled swells. Also for Mexico, that area does well with south-angled swells, but not so good anywhere else. The thought being this perpetual trough pattern over here is maybe a signal of what's to come this winter. We'll get more into that in a minute. All right, let's take a look at surface level pressure, surface level winds, and as you see, here is where the southern branch of the jet stream is, running right along here. So that's where all the activity is. Now remember, the ice line is right along here too. So much of whatever fetch you see here is over ice, Doesn't do anything good for swell production. Only makes for stormy days for penguins. Nothing for us. Anyway, and you see sort of cut-off lows. Remember, the other branch of the jet stream is running somewhere along here, so you get high pressure in between the two branches of the jet stream, and that's kind of what we're seeing. So we'll just roll this out, see if we see anything of interest. A little bit of a gale trying to develop on Tuesday, 35-knot winds at 60 south. Yeah, so that's north of the ice line, but all aimed off to the east. Here we go. Tuesday afternoon, 45-knot winds trying to build, pushing to the north, 50-knot winds over a small patch on Tuesday night, and then quickly moving out of the California swell window, just barely come later Tuesday night, and it's gone. All the focus there tends to be on Chile. Now, there's this interesting system here. I'll pull away from it just a second. You can see a little tiny area of 55-knot winds. This is a cut-off storm. No jet stream support here, really. Kind of a powerful-looking storm, and some fetch actually aimed to the northeast, but watch this. The system is falling southeast, and most of the fetch starts moving, taking aim at Chile. Probably nothing is going to result for Tahiti, California, maybe Peru, Chile. That's the main target, assuming it develops. And then it kind of goes. It merges with something over here on Friday. Let's see if anything comes from that. No, it kind of fades out. Then here comes two more systems come Saturday. We know there's a bit of a trough forecast to develop here. Sure enough, you see, what's that little tiny area, 40-knot winds, 35-knot winds here, 30 and 35-knot winds. That'll only get you 20, maybe 22-foot seas. That will fully dissipate before it makes the 4,000 or 5,000 mile journey up to California. So surf, again, Peru, Chile is the focus. Then we get into Sunday. Little patch of 45-knot winds, barely in the California swell window, building a little bit, but not much. Just a very small fetch, and we'll just roll this out. It's just about out of the California swell window. Remember, 117 west, roughly, somewhere in there. Again, this mainly looks to be supporting energy towards Chile and Peru. Oops, and that was the end of it. All right, let's go take a look at the wave models. And here we go, significant wave heights, South Pacific Ocean. We'll just roll this out. Nothing, nothing, nothing. 20, 22-foot seas, doesn't count for anything. Then we get into Tuesday night. Remember that gale over here? What's that? 33-foot seas, and there's your ice right there. So 65 is right there. Some of the ice is a little bit further north, some a little bit further south, but 65 is a good point. And that's pretty much typical for this time of year. We're well into the deep part of winter in the southern hemisphere. And there we go. What is that? Almost 32, 34, 36, maybe 37-foot seas in the California swell window, mainly aimed off to the east, but some energy likely to radiate north. So that gives us some hope. Most of the energy, though, towards Chile. Here comes our cut-off gale, if you'll call it, storm, whatever, into Wednesday night, developing 42-foot seas, but watch this, falling southeast, aimed east to southeast. No hope there. Roll this out some more, and then we have one more system forecast over in this region come the weekend. Does it do anything? Yeah, there you go. What's that? 20, 22, 24, 26, 28-foot seas. Okay, and maybe a little bit more. There you go, 30, little area of 34-foot seas. That's good possibly for something for Southern California. But again, a week out, never believe the models that far in advance. I'd say about 4 or 5 days is as much as I'd start believing it. So that is just a fantasy storm at this point in time. The short of it, Southern Hemi, pretty quiet for this time of year. We would be hoping for more, and then all the activity clearly is organized in the Southeast Pacific, and swell-wise the same, favoring Southern California, but really Mexico, Chile, Peru, that area. All right, let's go take a look up north. All right, looking at North Pacific significant wave heights, we're going back a week, July 23rd, and the focus here is all on the tropics. Nauru, right here off of Japan, that was the initial area of interest. And watch this, it was retrograding to the east. Normally, they're traveling to the west. So this system really did one of these things and then stalled, went south and southeast, and then east. And right here, come Tuesday or so, it lifted just a little bit off to the, here, we'll roll that back, a little bit to the north and east. Maybe producing a small bit of swell that was pushing towards Hawaii? Probably not. Whatever swell was generated has already arrived and gone, probably mostly focused on Kauai, small at that, and then taking off again off to the west. At the same time, Hillary and Irwin here developing. Hillary, it has generated swell, not large swell because its track mainly is off to the west. We'll call it west-northwest, but it generating small swell, and you can see it here. We'll just roll it back. You can take a look there. Off to sort of a west-northwest track. I think winds were up to 90 knots. 11-second, maybe some 12-second period swell moved into Southern California. Size was not impressive at all. Now also notice this as we go on. So Hillary and Irwin here, they'll start doing this circulation dance, Fujiwara effect it's called, when one becomes entrapped in the circulation of another and they sort of start rotating around each other. And you can see that there, just whoops, you can see it as they started moving north. And so, yeah, that's that. There was actually something like that almost going on over here in the West Pacific, too. All right, so now let's go to the forecast. And here we are. Forecast, we'll watch this. Both Hillary, Irwin fading out, no longer producing swell. This is as of Sunday night, but just a bit of an interaction between the two of them. It's interesting. But also watch Nauru over here. It stalls and is forecast to drift off to the north again come Tuesday night, Wednesday. I think winds up to 100 or so miles an hour. Let's take a look. So we'll start out with the satellite image of Nauru. Look at that, well-defined eye, very concentric circulation. Typically, when you have an eye that pops out like that, that means minimum winds 90 miles per hour, if not stronger. We'll take a look in a second. But just enjoy the symmetry of this system. Very impressive, looks pretty strong. Not doing a whole lot for us, but certainly for Japan. And the fact that it has been circulating off Japan for, almost a week now, certainly guaranteed surf at times moving into there. Just a wave-making machine. Okay, taking a look at the latest. So winds, let's see, 18Z right there. That's where the system is. Japan right here, Tokyo, Kyoto right there. So south, what is that? Where are we at? 23 and 33. So let's say maybe 700 miles due south of Tokyo. Winds right now 140 knots. Certainly that explains the great eye that we saw there. This is a significant upgrade from even this morning. And forecast to build into this evening to 145 knots. Now, notice here, it's taking this, west-northwest track. All that energy on the north and northeast quadrant of the storm, favoring this portion of Japan right here. Nothing for our area, but notice the forecast track here. Let's say on the first 18Z, that puts winds still 125 knots moving north. That would perhaps put some swell into Hawaii and California. Probably very small swell. Let's take a look at the Great Circle charts. Here we go. Relative to Hawaii, the storm is at 25 and 138, so right about there. So that looks like about swell from 288 degrees pulling into Oahu. So that's shadowed by Kauai. So this would be a Kauai swell, but probably nothing for the north shore of Oahu. And relative to Northern California, let's say 25, 138 right there. So about the 295 degree track into, we'll call it San Francisco. But the system is moving due north. Would really need to be moving northeast to push energy up the Great Circle track. And remember, this is a rather small pebble. Yeah, very strong 140. Well, it's down to 125 knot winds by the time it starts moving north. If it's moving northwest, it's totally perpendicular to the Great Circle paths. Nothing's going to result from that, especially given the 3 to 4,000 mile distance to California. So probably not a whole lot of energy for either location, but something to watch, and certainly an impressive storm. So anyway, back to the wave model charts. There's Nauru. It heads north like we saw, and then the interesting part, it almost approaches Japan, then backs off yet again. Another system out here, not sure whether it's tropical or not, hasn't formed yet. And look at these, just kind of spinning. Oh, and you get the sense that it's Nauru is to, look at this, we'll roll back. Now just watch the motion of this. Saturday, Sunday, of course, never believe the models, but actually, makes a push back off to the west. Very interesting. Japan, certainly to get bombed with piles of swell, but maybe some swell radiating off in this direction. Maybe, just maybe. Otherwise, looking back, this tropical system here on the charts was forecast to be much stronger. Now it's down to nothing. Wouldn't believe a wave model a week in advance for anything tropical. They're far more fickle. Tropical systems believe it maybe 2 or 3 days at most. But it's done pretty good in regards to Nauru so far. So that's it for the Northern Hemi. Let's go take a look. Let's look at wind swell for Northeast Pacific real quick. Here we go. Surface level pressure, surface level winds. We're looking for winds in excess of 15 knots aimed at from the east, either at Hawaii or from the north, California. We see a little bit of the typical summertime pressure gradient. Here's high pressure here, weak low pressure inland, heat low. The difference in pressure tightens the isobars, which generates wind 20, 25 knots. There's tiny little junky wind swell rolling into California. There's also south winds along the coast. It's called an eddy flow. Remember, low pressure here, so you get just a little bit of south winds right there. Anyway, roll this out. That continues. We see our 2 tropical systems fading out of no interest. The gradient continues into Monday night, building even a little bit, 30-knot winds, but still, it's very far to the north. And so whatever swell is generated, it's almost shattered as you get down into central California, but maybe little bits rolling into exposed breaks along the central and north California coast. Then the gradient kind of fades out completely. Light wind pattern. Looking at Hawaii here, we don't see a whole lot going on. Till we get into Friday, notice east winds, trades building to almost 15 knots, pushing into the Big Island, maybe Maui on Friday, and a little bit north there into Oahu. Friday night, maybe good for very short period junky wind swell. We'll roll this out. Notice high pressure building here. If it ridges into the coast, then we'll get wind swell. But looks like for the weekend for California, that's next weekend, not a whole lot of fetch forecast, meaning not even wind swell. Now here we see east winds continuing, but kind of patchy and very close to Hawaii. Probably not a whole lot from that. We get into Monday, and then you see the gradient starting to build in Northern California and continued sort of spotty east-northeast winds into trades into Hawaii. Good for very small, short period easterly wind swell. All right, let's go take a look long-term. Long-term outlook, what's going on with the MJO and El Nino Southern Oscillation Index? We're always, as always, looking to get a sense of what's going on, not next week, not the week after that, but a season or two out and even longer, trying to set our expectations. It's all about expectation management, right? If you have high expectations, you're certainly to be disappointed. If you have low expectations, you will not be disappointed, and sometimes you'll be pleasantly surprised. So let's go take a look. So we'll start looking short term. We're looking for some signs of the active phase of the MJO. The MJO is a periodic weather oscillation, travels from west to east across the equator in the Pacific. Here's the West Pacific on the equator to the east. When the active phase is in control, it tends to dampen trades in this area, if not out and out reverse them. That in turn imparts energy to the jet stream, both the northern hemisphere and the southern hemisphere. And being how this is the summer, if you have the active phase in the West Pacific, sometimes it helps to build the jet stream in the southern hemisphere, therefore helping to generate storms and swell. The effect is more noticeable in the winter relative to the Dateline region and the Gulf of Alaska. So right now, trades in control. This data from the TAO buoy array, actual buoys strung in lines across perpendicular to the equator, looking for signs of westerly wind bursts or slackening of the trades. Right now, actual trades from the east the whole way across the Pacific. Looking at anomalies, differences from normal this time of year. We're just looking at the arrows and basically dead neutral in the East Pacific and weakly out of the east. So that means that trades are not suppressed, certainly not blowing or anomalously from the west, suggesting perhaps a weak instance of the inactive phase of the MJO. Looking for corroborating evidence, 850 millibar wind anomalies. We're really interested in the Kelvin wave generation area. That's in the West Pacific. Here's the equator right here. That's South America. There's the maritime continent, Australia, Philippines there. The Kelvin wave generation area from 135 east to about 170 west. Box right in there, 5 degrees north and south of the equator. We see easterly anomalies on July 24th, and we'll just scan the charts going down here. And we see this perpetual kind of weak easterly wind anomaly pattern up until the 28th. A little bit of westerly anomalies start showing up. So the thought was we were in the inactive phase of the MJO. That should be moderating right about now. Let's go take a look at the forecast charts. Okay, and here is also hindcast. So the Kelvin wave generation area, 135, this is 120 east. This is the date line here. So Kelvin wave generation area from about there to there. And you go down, these are past dates here. Blues, purples are easterly anomalies, pretty strong. Sure looks like the inactive phase of the MJO set up towards the latter half of July and was in control. Here's where the forecast starts. The inactive phase of the MJO appears to be moving off to the east, and as of right now is just on the eastern edge of the Kelvin wave generation area. A little bit of westerly anomalies trying to build in, but then as we get towards August 6th, it looks like easterly anomalies again forecast, which suggests this perpetual, and this has been the issue for months and months and months now, this bias towards easterly anomalies. The active phase tries to organize, it doesn't there. The inactive phase always seems like it's in control. Classic signs of some sort of La Nina pattern in the atmosphere. And thinking about it, we had El Nino all of 2014, 2015, 2016, and now this sort of La Nina pattern is setting up, not unexpected, completely normal given almost 3 years of El Nino prior to that. Let's look for more corroborating evidence of what's going on now here. Outgoing long-wave radiation models. The more sunlight reflectivity, like here, positive numbers, means high pressure, means the inactive phase of the MJO, means no clouds. Blues suggest less sunlight reflectivity, more clouds, suggesting the active phase of the MJO. So according to this, the active phase of the MJO is in control, kind of weak looking though, and forecast to dissipate or nearly dissipate about 10 days out. That's pretty, and this is the statistic model, and that seems to be pretty well in agreement with what we saw on the GEFS model in the charts before. And here's the actual GEFS model. It suggests the active phase of the MJO is over the Kelvin wave generation area, is withering, but is not supposed to give up the ghost, is supposed to hang on 2 weeks out. So a little bit of difference between the models, but certainly in the short term, about the same thing. Weak inactive phase of the MJO in control. Very limited support for storm development in the South Pacific. And what we're seeing is whatever that enhancement is, it seems to be limited to the Southeast Pacific. Looking at phase diagram charts for the ECMF model, so assume you're looking down on the North Pole. We're looking where the active phase of the MJO is. Here's the dot. That's where it is. It's in the Western Pacific on the equator. And the forecast, if it's inside the circle, it's considered to be very weak. The next 2-week forecast looks like it's supposed to basically be somewhere around the date line, crashing and dissipating to nothing per the ECMF model. The GEFS model basically says the same thing, maybe not crashing as hard, maybe retrograding to the west over the maritime continent. That explains why the previous model, the GEFS model, suggested that the MJO is supposed to linger but sort of backtrack over the West Pacific. So all this is in agreement. Regardless of that, the upper level model suggests, so if you see greens, that's areas supportive of precipitation and could roughly be correlated with the active phase of the MJO. Looking at this, right here's where we are. It says no active phase of the MJO, no real enhanced support for precipitation, kind of dead neutral, and clearly the inactive phase of the MJO is somewhere in the Indian Ocean. Now remember, this model runs about 2 weeks ahead of the other models, and if anything, the inactive phase is to be building, moving its way across the Pacific for the next 40 days, and even once it's over in the East Pacific, whatever active phase is supposed to follow it is supposed to be very weak. The theme being here, the atmosphere is biased in favor of the inactive phase of the MJO. That's clearly a hallmark for a La Nina sort of pattern. Let's go take a look and see what's going subsurface in the ocean. West Pacific here, East Pacific here. Absolute temperatures, again from the TAO buoy array. Here's the location of the different lines or walls of the buoys. These are the sensors on the anchor lines. You can see warm water, 30 degrees Celsius. In the West Pacific, not so warm water in the East Pacific. And what we have noticed here, the 28 degree isotherm right here, that's typically what's used for measuring sort of where El Nino, the threshold is. The further this pushes off to the east, the better. If anything, it was over somewhere around, I think it was around 135 or so a couple weeks ago. It has backtracked considerably. It's back to about 158 or 159 west. We're also seeing the same thing with the 24 degree isotherm right here. All summer it's been up, reaching into the Ecuador coast. It is backtracking now at about 105. The depth of the 24 degree isotherm here was down around 100 meters 2 weeks ago, or even a little bit 3 weeks ago, but now is up to about 75 meters. So what this says is whatever warm water is here is weakening, getting shallower, and backtracking. Those are weak La Nina symptoms. If you see this get considerably more pushed off to the west, then that suggests stronger La Nina. All right, let's take a look at anomalies, difference from normal for this time of year. And what we're seeing right now is pretty much a dead neutral pattern. Yeah, a little pocket of 1 degree above normal anomalies in the West Pacific, a little bit off of Ecuador, and dead neutral in the middle. We're starting to see this bubble of cooler water, 2 degrees below normal, building up a little bit higher in the depth of the ocean here, but not a whole lot, up to 75 meters. So this might help explain some of what's going on in the East Pacific, but not all of it, and you'll see why in a minute. Another modeled version of what's going on at depth, basically the same thing, pockets of warmer anomalies, but kind of just basically a neutral pattern on the surface going from West Pacific to East Pacific. Little pockets of cool at depth, but nothing significant one way or the other. Kind of a dead neutral pattern, neither El Nino or La Nina in the ocean. And looking at sea level anomalies, this is Jason 2 satellite. Strip out all the winds, strip out all the waves, the tides, chop anything. And where you see bubbles, if they were along the equator here, South America, Australia there, if you saw a bubble, a positive bubble, that suggests warm water at depth. Of course, warm water expands at depth, and that creates a little bubble at the surface. If you saw a hole, a negative anomaly here, or here, something like that, then that would suggest cooler water at depth, and that would suggest, especially if it was right around in here, that would suggest La Nina. We're not seeing that. Pretty much a dead neutral pattern. And then upper ocean heat anomalies, 300 meters, now back in time, September, October 2016. We had our La Nina after the big El Nino. It was a very weak La Nina. We kind of marveled at how weak it was. We were rubbing our hands in hopes that it didn't build, and certainly it didn't. And if anything, we're going, well, maybe it's gone. Well, maybe it isn't. Okay, we saw warm water building in here in January 2017, not warm water, but neutral water. And we go, gosh, La Nina's dead already. Hard to believe it. We saw this little push of warm water here, almost a Kelvin wave. And then we got this buildup of warm water off of Ecuador, Peru. They even experienced sort of a mini El Nino down there. A lot of rain, a lot of wind, stormy conditions along the coast of Peru. Didn't do a whole lot for surf. It wasn't a very cohesive or integrated signal across the globe. Not really an El Nino, but just like a localized El Nino. Then sort of an upwelling phase of the Kelvin wave cycle, a little bit of cooler water, another push, and then this guy dissipated in July. Notice there was warm water over here, and whatever warm water was here made it to the east in those two pushes, and it dissipated too. So typical La Nina signals would be cooler than normal water over here, a lot of warmer than normal water here. We're not seeing that. What we're seeing is just this dead homogenized pattern now in control over the whole Pacific. Not a lot of warm water buildup anywhere. The point from that being that we had this El Nino thing that went on. I won't have a picture, but I'm just going to talk it here. So think your way through this. The big El Nino, it started February of 2014. It didn't really do a whole lot the fall of 2014 into the early winter 2015. But then the super El Nino part and all the hype with it occurred as we got into the fall of 2015, into the winter of 2016. Then last year, winter of 2016, early 2017, we thought everything was over. We had remnant moisture in the atmosphere from El Nino, but at the surface it was this. It was a La Nina pattern. That created all the rain for California. We did have a good little pulse of swell by little, some 25-foot day or two into California in November. Another little pulse in January of 2017, but by and large, the surf was not good in California the last winter. And the same for Hawaii, suggesting that certainly El Nino was dead, but it wasn't a full La Nina yet. We're going to go somewhere with that. Just hold that thought for a moment. So we'll continue our tour here. Let's take a look at surface temperature anomalies. Okay, so we had a lot of warm water, early summerish time frame off of Peru. This is what we were thinking. Gosh, there's some sort of like El Nino thing going on, but it has considerably dissipated. Yeah, we have a couple little pockets here. We have some pockets here, but we also have cooler water off of Ecuador. Not really very much upwelling along Peru or Chile for that matter, but there's this pocket kind of down here. And if you look at this whole thing in balance, if you draw a line right down 120, you see neutral to maybe slightly cooler on the balance. And you go from here this way and more warm water here. Just keep that in mind as we go take a look at the next chart. The trend for the past 7 days, pretty much neutral. Not a whole lot going off Chile, Peru. Alternating pockets of warm and cool, but kind of this whole area out to 160 now, in general, is kind of volatile and appearing to be getting cooler. Let's take a look at yet another chart. So here we go. Sea surface temperature anomalies for the whole Pacific Basin. We see this kind of alternating pockets of cooler water, not really cold, and working their way the whole way through. So the Nino 3.4, Nino 1.2, it's this area here out to, we'll call it about 120, something like that. And this is a very volatile area. It gets hot and cold. It does all kinds of stuff. Very noisy. But whatever happens here eventually travels, advects off to the west, following the trade winds here. And what we've seen right here, 5 degrees north and south, not the Kelvin wave generation area, which is over in here, but this is sort of the result of what happens in the Kelvin wave generation area. Sea surface temperatures between 170 west to 120 west. This is called Nino 3.4, and 5 degrees north and south of the equator. What you see right here, this thin little stream, it looks like a cool stream developing along the equator. And we were talking earlier, there's this, it just feels, looking at all the data, it doesn't say, it's not screaming La Nina, but it's certainly saying, certainly not El Nino, and now it's starting to say, certainly not warm, maybe signals of some sort of weak La Nina-ish patterning developing for the fall and winter. At least that's what it looks like at the moment. And there's a lot of other data that just generally points in that direction. Certainly the inability for the active phase of the MJO to get any legs at all whatsoever in the West Pacific is a sure sign. And this perpetual bias for easterly anomalies over here, that's what would be causing this cooling in this region. And the cooling ultimately is what drives you towards La Nina. All right, let's dig a little deeper. Southern Oscillation Index, difference in temperature or in surface pressure between Darwin, Australia, and Tahiti. Very good for trying to tease out the active-inactive phase of the MJO, but also for seeing what's going on in the atmosphere regarding La Nina, El Nino. Daily index, always very noisy, but for the past 17 days, you can see it. It's been positive, other than one negative reading here. Positive, certainly indicative of the inactive phase. Positive numbers mean the inactive phase of the MJO. Long-running values, positive, suggest La Nina. All right, the 30-day running average, good way for sort of getting the noise out, kind of getting a sense of what's going on with inactive, active phase of the MJO. Current value, 6.4. Positive numbers, again, suggesting the inactive phase of the MJO in control. The 90-day running average right here, good for teasing out El Nino, La Nina, was kind of looking, you can go back here, kind of looking negative, meaning El Nino-ish, but is certainly getting more positive. Still, just dead neutral now, and that's fine, but this is maybe more, this is what's happening in the atmosphere. We're thinking what's going on in the surface and trying to tease out what's going over in the Nino 1.2 region. Sort of suggests maybe we're heading towards at least neutral, if not weak La Nina. You can see the 30-day SOI average here. Actually it started in January 2014, the index going negative, and then 2015, fall of 2015, very negative, down -25. That's a 30-day running average, and still holding into April. Then we had this turn, July 2016, towards La Nina, positive values, and now we had a turn back to neutral, right? Okay, and you can see the inactive phase, active phase, inactive, active, and you see it cycling through, but you're drawing a trend through there to get a sense of what's going on overall. And see the active phase, we're in it right now, or the inactive phase, we're in it right now. The question is, will this trend line starting to go up, or will, right now it's actually just hovering right around zero, or will it hold there? We're trying to figure that out. That's the whole point of trying to guess what's going to go on this fall and beyond. One leading indicator is the ESPI index. So instead of differences in pressure like the Southern Oscillation Index between the area north of Darwin, Australia, and Tahiti, this is absolute rainfall. The drier it is in this region, the more negative the index is, the wetter it is, the more positive. So this was hovering around zero for a long time, and then about a month or two ago, it started crashing negative, went down to -2, and that's pretty negative. That's more negative than it was. I think we were down to -0.78 or something like that last year when we were in La Nina. So now we're back again, and this is a leading indicator. The ESPI index often leads what goes on at the ocean in terms of surface temperature by about 3 months. So, and then today's value, -1.68, certainly indicating some sort of a La Nina pattern here. So there's some evidence suggesting La Nina is trying to develop. So let's go look at the forecast from the CFS model for the Niño 3.4 region. And here we go. You see, here we were. Here was January 2017. Sort of sea surface temperatures a little bit above normal in this year. Not El Nino-ish, but just biased warm, about a half a degree for 3 or 4 months. But here's where we are now, crashing and temperatures going down. Now this isn't bad. This is half a degree below normal, and only for a couple of months. That's the forecast for January 2018. This is for the Niño 3.4 region. You go, that's not too bad. That's normal. That's neutral. But let's take a look at distribution of some of those temperatures. So here we go, August 2017, and notice the blues right here. This is Niño 1.2, Niño 3.4 was south of California. This is a very small picture. So you can see here it's kind of, slightly warmer, slightly cooler, neutral basically. September, October, we're going somewhere with. As you get into November, here's the date line. Notice you have blues, which are slightly cooler than normal, not a lot, and over a thin area, building into January 2018. This clearly looks like a pretty classic weak La Nina pattern by 2018. Now notice this chart suggests that quickly after that those temperatures crash and we return to normal. So who knows? But the point being, there's a fair amount of evidence that suggests that we're moving into some sort of a weak La Nina for this winter. And you go, oh, that's not good. Well, let's try to put things in perspective now, okay? And we're going to jump off probably into the deep end of the pool here real quick, but we'll do it quickly. Okay, so the point being, yeah, so maybe we'll have La Nina this winter, or a weak version of La Nina. That's certainly going to step on surf heights. It will probably certainly step on water into California. In fact, we'll do this real quick. Forecast again from the CFS model, 850 millibar wind anomalies. We're not going to get into all the details. The short of it is some sort of a weak dispersed active phase of the MJO over the dateline region right now, inactive phase following behind it, supposedly an active phase running well into the fall with weak westerly anomalies. We don't believe any of that because that was supposed to have happened a month ago and it hasn't happened, and we don't believe that will. What we're really getting at is the low-pass filter here. This suggests, and as you can see it from last year, notice this was La Nina. The dotted pattern suggests the La Nina over the dateline region, which is right here. Same pattern developing again this winter, this would not be surprising. That is, so we had this, our El Nino from 2014. It tried to happen. It sort of faltered. It didn't discharge heat. It came again in 2015, 2016, much stronger, declared to be a super El Nino, did a lot for producing surf, but not anything like just magnanimously over the top. And then it still hung around even last year, even last winter, it was still there. So this is, now remember, the Super El Nino of 97, 98 was a one-year event, very concentrated, very strong. This quote-unquote Super El Nino was a 3-year event, could never quite discharge heat. And, and that's what really El Nino is all about, is just discharging excess heat that's built up in the ocean. It's way more complex than that, but that's basically what it does. That's what hurricanes do. They vent heat off the ocean up into the upper atmosphere and try to cool things down. So hurricanes do that. The MJO, in a way, does that too. And El Nino, La Nina does that. Now, the next point of it, the PDO, Pacific Decadal Oscillation, does that too, but hurricanes are over a period of week, the MJOs over periods of, 4 weeks at a time, the El Nino, La Ninas over periods of 4 or 5 years at a time, and then the PDO is over periods of 15 to 25 years at a time. We're going somewhere with this. The PDO, okay, right now we go pull up all the numbers, but basically say it's weakly positive, suggesting the warm phase of the PDO, which is like a long-running El Nino. It's more favorable for El Nino development. Now, that started, we think we went from the cool phase of the PDO. Cool phase started when right after the Super El Nino of 97, 98. We went into a 15-year hole after that. That's not to say you don't have El Ninos, but they're very weak, kind of not well organized. That's exactly what happened. And we're thinking that with this the last strong El Nino of, we'll call it 2014 to 2016, we kind of turned the corner and we're moving towards the warm phase of the PDO now. And that would be good for us for the next 15 to 25 years in terms of storm production, in terms of water into California. Also, remember that 5-year drought that we just came out of? That also might have been tied to the fading last bits, the last stand of the cool phase of the PDO cycle. All right, now throw some more data at you. Now, regardless of the source, one cannot argue based on satellite data alone that glaciers in the northern hemisphere and the extent of sea ice in the Arctic has been shrinking steadily year after year. Okay, there's heat building up in the ocean. Also, there's plenty of evidence looking at all the long-term sea surface temperature records that the oceans are continually getting warmer. We're not talking, huge changes, but a tenth of a degree every 5 years sort of thing, maybe not even that. But there's this sort of latent heat buildup, tendency to build up heat in the oceans, okay? That heat has to go somewhere, right? Generates hurricanes. In fact, there was a study that came out just last week. Again, one study, you can take it with a grain of salt, but it theorized, and they were trying to run models and trying to prove whether as temperatures increase, whether that helps create more El Ninos. Logically, just thinking about it, one would say, well, yeah, I mean, if El Nino is a way to vent off heat, then of course there'll be more El Ninos and they'll be stronger, just like there'll be more hurricanes, just like maybe the active phase of the MJO will be stronger, et cetera, et cetera. Okay, so the thought being, well, if heat's building up, maybe that's also what's helping to force the change in the PDO. We'll leave it at that. Don't know, just making stuff up, something to consider. Anyway, so for now, 2 small southern hemi swells are approaching they're hitting Southern California. Nothing big, nothing large, probably much bigger into Mexico, South America, that sort of thing. Long term, this winter, probably some sort of a weak La Nina thing going on. Nothing strong, nothing major. They might not even declare it La Nina, though looking at the sea surface temperature chart, it sort of looks like they will. But that's not unexpected. We had a little bit last year, a little bit this year. Maybe that'll be the end of it after that, and then we'll move into a warmer regime and be done paying the price for the 2014, 15, 16 El Nino. Other than that, wind cell pretty weak for the coming week, and just basically, other than the southern hemi swell, not a whole lot going on. The interesting part is the hurricane season, though, is still reasonably active in the North Pacific. That was unexpected, but again, that's probably a result of a fair amount of heat in the oceans that is not it's dissipating, but slowly. Hangover from the 2014, 15, 16 El Nino. So that's it for this week. We're all caught up. We'll do it again next week. Same time, same channel. Thanks for watching.